The next thing I want to try here is equal risk contributed portfolio. As you can see right here, PERC, which is equal risk contributed. If you want to build a portfolio with equal risk contribution, like each of these different stocks will come with like equal risk. So it's like you are risking the same, you are taking the same level of risk for each of the different stocks or each of these 6 different stocks, which is called PARC. So to build that, for you to build an equal risk contributed portfolio, you need to obtain the covariance, of the return series. Because we have 6 different tickers, we need the covariance. So I'm going to build something here that I will call sigma. Okay, the sigma will actually be covariance, of the return series. So covariance, and our return series, remember, is RT. RT is actually our return series. So when we build the covariance of this, after the covariance, we can now use the same function that we use right here to get the return. To get actually our portfolio with equal risk contributed. So my portfolio number 2 is going to be, okay, PERC, which is portfolio with equal risk contributed. Okay, we are going to use, instead of, for the first one we use the return series, right, to get the most diversified portfolio. For this very one, I'm going to use the sigma, which actually represent the covariance, right. Instead of return series, it represent actually the covariance of the return series. So I'm going to run these 2 lines of code, and we are going to obtain our portfolio, equal risk contributed portfolio. So optimal solution, we are waiting on our optimal solution, which is P2 right here. So the P2 is going to give our optimal solution. So clearly you can see P2 is right here. That's the optimal solution. For us to have an equal risk contributed portfolio, we need to invest 19% of S&P 500, 18 right here, 20% of these, and so on. So these are the different combinations, different percentages, right, that we need to combine for each of these stocks or each of these ticker if you want to get an equal risk contributed portfolio. So yeah, there is a lot to explore, on this book. It's a very interesting book, and this package is right here, on R. It's called FRAPO. Okay, FRAPO. You can explore it right on your own. There is a lot to do, here. Different models with different financial models, could be built off of this package right here. So after obtaining our equal risk contributed portfolio, we are going to use the equal risk contributed portfolio to actually plot out, the return series for that very portfolio. So earlier on, remember, we already have the return series. We already have the return series for the various stocks, right? And we can even run this again and see how it looks. So actually, I can, instead of seeing everything, I think I will look up to the head of the return series for each of the stock. So that's how this look. So we do have here each of these return series for the return series, for each of the stock. Now I'm going to use this return series along with the portfolio that we just built up here, the P2, that has to do with equal risk contributed portfolio. So we already know each of these tickers, how much they contribute, for us to have an equal risk contributed portfolio. We already know the percentages of S&P 500 and each of these tickers, to make up an equal risk contributed portfolio. Okay, we already know this proportion, so we are going to use this proportion, which is actually P2. P2 is actually the proportion right here. So this is the proportion of S&P, 19% of these, 18%, and so on. These are the proportion of each of these tickers that needs to be combined to obtain an equal risk contributed portfolio. So what I'm going to do here is just to obtain, I'm going to actually get these weight, because these are weight right here. Each of these represent the weight. So I'm going to create, okay, a function here that I will call weight. Okay, and this will actually extract, the weight out of the the portfolio. So this will be weight. Okay, we are going to take, the weight out of the P2, which represent actually the equal risk contributed portfolio. So now when we get this weight, and actually we can actually look up to the first weight, which is going to be 19 point, and then when I get this weight, what I'm going to do actually here, I'm going to, so that's how the weight looks like. Let me drag this out. Let me look up to the first one, W1. This is what it have, S&P 19.89. So that's actually how my first weight actually looks like, right? So what I'm going to do here basically is to use these, right, to obtain the numeric value, because I want to just obtain those values like 19, 18, and so on. I do not want to have the header like S&P N20, 220. I don't want to have the header. I just want to have the numeric values. I'm going to use these and multiply by the return series to obtain the total return, for this very portfolio. So here I'm going to create a function called here sigma, and sigma is actually going to be as numeric. And as numeric, what I'm trying to do here is to get the numerical value of the weight W. So, and then I'm going to divide this by 100, because remember, right, 19.89 is a percentage, is 19.8%, right? I do not want to use percentages, I want to use decimal. So you divide 19.8 by 100, it's going to give you the decimal, which will be 0.198. That's what I'm trying to do here with this value. Now when I obtain this value here, instead of having, I think I will change this. Actually, I'll call this maybe a Z, right? It's better because sigma is so long as a denomination. So yes, I'm going to get the Z here, which will be as numeric of this, right, and then divide by 100. And when I do that, each of these value is going to be a decimal. And actually we can take a look at actually the first value and see how this look, actually Z1. So let me run these 2 lines of code and we are going to take a look at the Z. So this is how the Z look, 0.19 and so on. So this is actually getting a decimal of this right here. Come down here, portfolio return, let me call it portfolio return. So I'm going to call this portfolio return, right? Portfolio return, and this is going to be something like multiplying each weight by the return series. So the first weight is going to be because my weight right here is Z represent actually the numerical value of the weight. So the first value is Z1. Okay, I'm going to multiply Z1 by the first return series, which is actually S&P 500, the first return. And I'm going to keep on doing that until I reach out all the 6 stacks. The second one is going to be Z2 that I'm going to multiply by R, the second return series, which will be R2, right? And I'm going to keep on doing that until I reach the last one. Now fast forward, okay. All right, cool. So that's what we have here. Okay, so we have all of each of the tickets, right? We have 6 different tickets right here. The first one is S&P and this one up to HSI. So we multiply each of the return series by the corresponding weight which represent actually the proportion, right? That very stock to be invested in to make up an equal risk contributed portfolio. So now what I'm going to do, and actually we can look up to the head of this, right? So portfolio return, and then we can look up to the head of this, right? So maybe the tail, because I've been looking up to the head for a while now. Let me look up to the tail here and see how the tail looks like, right? So let me run these 2 lines of codes, and that's what we have. That's the return series. Now clearly you can see it picks up the first one, which is S&P 500, because we're supposed to have something. I mean, that's the first one by default, because we have 6 different tickets by default, because this is just one column which represents the overall return. So clearly you can see in 2011 January 31st, the return, for the overall portfolio, it was a positive one, which was a profit 1.27, right? And then you can see and so on. What I'm going to do is just to change the header here, the column name. I'm going to change it to something different. So column name, so right, okay, and then let me put this name right here. So I want to name my portfolio return, right? I want to give it a new name, and that new name I'm going to make it combine, and I'm going to put the same name actually, portfolio. I'm going to call it portfolio return. So let me make this so portfolio return. So I'm going to call this portfolio return, okay. And now if I'm to run back this line of code to look up to the tail of these, we are going to have a different name now. Portfolio, instead of S&P, we have portfolio return. With that being said, I'm going to plot out, that was where we're heading. We are going to plot, right? We are going to plot So let me write something here. Plotting the portfolio return with plot function. Okay, with plot function. Okay, now I'm going to write here plot. Okay, and I'm gonna put here portfolio return. Okay, $sign, then I'm going to put the name that I actually created right now, and then we can see how this looks. This is how my portfolio return. Let me zoom it out. This is how this is how it looks right here. See, this is what it looks. But right now, clearly you can see it's kind of balanced. It's kind of like symmetric, but we cannot appreciate this better unless we are. So what I'm going to do here is simply to I want to create an AB line here. So let me do this, right? I'm going to create a line, right? So I'm going to create here AB line, okay, so that we're going to have a horizontal, a zero line here, AB line. I'm going to create something like 0 0, okay. And with that being said, we can run this, and it's going to create a line here. Clearly you can see the line is right here. So if I zoom out, you will see how this looks. This should look better now, and we can see, right, when you look up to the graph, clearly you can see here now we have an AB line here, and it shows that there is a balance. Okay, we do have like some outliers here. Clearly you can see this is between, right, the graph, this is between the return series between -10 and 10, to say this is kind of bad because we were building up like an equal risk contributed portfolio. Below -10 here, we may consider these as being outliers, right, because we do not have that much return series down there. These are extreme values actually, you know, towards the tail, right? So clearly you can see this is how this looks, and hopefully this helps you further. I mean, this helps you, you know, more explore the book and your financial models and stuff like that. There is a lot on, you know, in the book that, you know, that can be explored and work on. So I thank you for watching this video, and then I will see you on the next one.